Welcome to Pachehra Talks. Today, in continuation with Azure AKS cluster security, these 2 points which were left in the previous video, we are going to complete these. So let's start it with the Linux node updates in AKS. Maintaining the security and stability of an AKS cluster involves regularly updating both the Linux and the Windows nodes. However, there are different ways of doing it, or maybe there are no ways to do it. Why? Because in case of Linux, it's Microsoft who takes care of all the updates. In case of Windows, there is no inbuilt process that we need to follow like a traditional patch management of VMs. So what we need to do? Well, we need to take care of certain things. Let's start with the Linux nodes. AKS automatically applies security patches to Linux nodes every evening through the default distribution update channel. Okay. This automation ensures that nodes are kept up to date with the latest security patches without any manual intervention. So every day it's been patched. Okay. What is the security benefit? Automatically patching Linux nodes helps protect against vulnerabilities that could be exploited by attackers. We all know that that's why we patch. We have already covered these points in our previous videos. So when it is patching, it may possible that it requires a reboot. Okay. So this piece is something that needs to be considered. And who will consider this? Our AKS administrators. Since we talk about modernization, we talk about latest technology and automation. So how can we automate this reboot require situation? Well, there is a particular process that can be achieved through the daemon set because most of the time it doesn't require a reboot, but some security updates such as kernel updates requires a node reboot to finalize the process. And when it requires a reboot, there is a file gets created under this location. Okay. So what can you do? You could create an automation where it will find out if the file is present or not. If it is present, it will reboot the node. So you can use your own workflows and process to handle node reboots or use KURED to orchestrate the process. What process? With CURD, a daemon set is deployed that runs a pod on each Linux node in the cluster, and these pod in the daemon set watch. Watch for this file, right? Watch for the existence of var1 reboot required file, and then initiate a process to reboot the node. That's how you can uh, automate the process as well. And all the patches were deployed by Microsoft, so there's nothing much to worry about apart from the reboot thing. And we already mentioned some important stuff here, but the point is Windows thing. Point is Windows node update because there is no native process to patch those nodes or Windows nodes like a traditional VM patching. Instead, AKS leverages node image upgrade approach to keep the Kubernetes nodes up to date. So what we need to do? We need to upgrade the AKS cluster. So node image upgrade is the solution for the patching in Windows nodes. All right. Now, This process involves updating the nodes with new VM images that include the latest OS patches and Kubernetes components. Now, Microsoft updates all those operating system images on the marketplace every month once the latest patch is released. So, with the latest OS image, we need to upgrade the cluster. Now, what we need to do first, we need to check. What we need to check, we need to simply check if there is a new node image version available. And how can we check this? With the simple commands like this: AKS get upgrades resource group and the name of the cluster. this will this command provides a list of available Kubernetes version for your cluster along with the node image version. Okay, and we are looking for the node image. It will give us both the information, cluster version and image version, right? Now we need to plan for certain things when we are going for this kind of upgrade or process to upgrade with the latest image, like the plan for the downtime, backup, and compatibility. And to upgrade the nodes to the new image version, we generally need to perform a cluster upgrade. Now, if you're wondering, but we don't need to upgrade the cluster, then it is called cluster upgrade. Why? Because we are upgrading the image. That's why. See, AKS upgrade and then node image only. It is upgrading the cluster, right? Not upgrading the version of the cluster, AKS cluster, but the images. So the node image only flag ensures that only the node image is updated without changing the Kubernetes version unless you specify a new version. So after the upgrade, you should verify the new node images have been deployed successfully and then your cluster is functioning correctly, right? And that's how you can apply this process. But there are certain things that you can still keep in mind. What are those things? Well, what if you're running some sensitive information, right? Sensitive data on your cluster, some sensitive application. So you can upgrade, because if you're doing this, it is automatically upgrading everything with the simple process of node upgrade AKS cluster process, like adding one node, removing one node, adding one node, removing one node. But you can also do that manually through the process of hardening and draining. If you perform that manually, that is the process. So in this process, we'll stop deploying pod on a particular node, let it drain all the pods and move it to the next node, and then you upgrade that particular node and remove the old one. That's how you typically do this process. So cordon the node to mark it as an unscheduled or preventing new pods being scheduled on it. That's what the cordon is. And drain the node to safely evict all pods respecting Kubernetes scheduling and disruption rules. That's what it means. So this approach is often used in sensitive environments where the deployments require specific timing or coordination, or when integrating with complex operational procedures that aren't fully automated. Right? So that's how you can do manually as well. All right, so that's how we take care of Linux and Windows patching thing, but you need to plan it properly, right? And if we need to conclude the entire security AKS cluster security best practices, so these are the points that we need to take care of. First, we should enable the threat protection, which is Microsoft Defender for Containers, which helps us in four domains: security posture management, vulnerability assessment, runtime threat protection, which is real time deployment and monitoring. Then we need to secure access to the API server. There are multiple processes that we talked about: RBAC, and tried integration, whitelisting the IPs, network policies, NSGs, Bastion, Key Vault, audit log, a lot of things. And then restrict access to the instance metadata for lateral movement, data exfiltration, escalation of privileges, and this is the IP address that you can use in your network policies. Then you should regularly update to your Kubernetes to the latest version, and then Linux patching and Windows patching that we covered in this video. All right, so I hope it was informative, and these were those points that we talked about in the previous video when we secure content access to the resources, right? And in today's video, we completed the patching of Linux and Windows, and this is regularly update to the latest version. All these why we need to update it because of all these things and how. That's how things that you need to keep in mind. So I hope you liked it. It was helpful. Something new you learned. And thank you for watching. And you guys have a wonderful day. Bye bye.